Hey, welcome back. We are going to continue the 2017 Calculus AB exam. We are going to do questions number 21 through 30, and we're going to have some fun. We're going to have some fun doing them. I feel like this is going to be fun today. All right, well, without further ado, this is the end of the part 1. Well, I say section 1, part A, and we still do not get a calculator for this part of the exam. Don't fret. I'm your buddy, and I'll be right here with you. Let's start this. Number 21. If f of x equals the ln of x, then the limit as x approaches 3 of f of x minus f of 3 all over x minus 3 is. All right, well, the first thing you should realize is this right here is how you find slope. Okay, and slope is the same thing as derivative. This is change in y over change in x. Or in calculus terms, that would be f of b minus f of a all over b minus a. Okay, sorry about those b's, they're a little flat. No pun intended. So really, what I want to do is just take the derivative of this. The derivative of the ln of x is 1 over x. And I want that where? At an x value of 3. All right, well, that's just 1/3. Done and easy. Boom! See, it's going to start out fun. But wait. We'll get to those challenging ones. Big thing here is you need to recognize that this is slope. Then the problem is cake. Well, I hope you enjoyed 21 because 22 is going to be a little bit of work. Which of the following is a solution to the differential equation dy dx equals 2y over 2x plus 1 with the initial conditions y of 0 equals e? All right, for any x value greater than -1/2. All right, here we go. This is going to be some work, so let's just get right into it. Differential equations, I have a y variable, I have an x variable. I'm going to have to get my y's and dy's on one side, and my x's and dx's on the other, and then I'm going to have to integrate both sides. We did a problem like that on the previous video. It was problem 14, okay, of the same test. So to have two separable differential equations in multiple choice, that's just dirty. But you know what? Let's go ahead and do these because we can. The first thing I'm going to do is I'm going to multiply this side by 1 over 2y and multiply this side by 1 over 2y. So now this cancels with this. Okay, and on the left side, okay, let me get rid of some of this red here. Now on the left side, I need to get rid of the dx because I only want my y and dy here. So on the left side, I'm going to multiply that by dx. This will cancel with this. And I also got to do that to the right side, dx. So when everything is all said and done, I have 1 over 2y dy on the left, and I have 1 over 2x plus 1 dx on the right side. So let's just go ahead and do this. 1 over 2y dy equals 1 over 2x plus 1 dx. Woo! All right, so what I'm going to do is the following. All right, what I'm going to do is the following. I've got to integrate both sides. I'm going to pull my 1/2 out as a constant. So it's going to be 1/2 the integration of 1 over y dy equals, we really should do a u sub on this right side. I mean, I can do it quickly in my head, but let's say if u equals 2x plus 1 du equals 2 dx, okay, which means 1/2 du is going to get substituted in for this dx, okay? Because the previous equation here, where I just had du equals 2dx, I only have a dx. So I want to get this alone, so I multiply both sides by a half. This cancels, and that's how I get my 1/2 du. Okay, so now, and for my equation, I have the integration of 1 over u, and then my 1/2 du. My 1/2 will go on the outside. Okay, at this point, if I want, I can multiply both sides by 2 and get rid of those 1/2s. That's what I'm going to do. Make it easy. All right. Well, this isn't bad. It's going to be the same result. The integration of the ln, or excuse me, the integration of 1 over y is ln of y. I have my plus c equals, same thing, the ln of u plus my c. Okay, these are separate. The c is not getting involved with the natural log here. One step before I go even further, I got to substitute back in for my u, meaning u was 2x plus 1. So I need to put 2x plus 1 back into the equation. Okay? So I've got the ln of y plus c. Oh, there's me phone. All right, glad I answered that phone call as an administrator. But on the left side of my equation, I have ln of y plus c equals the ln, and I'm going to put my 2x plus 1 back in for my u. Okay, that's all we're doing at this point, plus c. Well, if you remember from problem 14, at this point, I am going to, these c's are like two different constants. I mean, they could be the same, but they could maybe not be the same. So what if I subtracted a c from both sides? Okay, c1. And I got rid of that. Boom. Because I ultimately want to get an equation where it's y equals. So I'm trying to get my y alone on the left side. The ln of y equals the ln of 2x plus 1. And if I combine two constants, that's just going to give me another constant. So I call that c. Now I have students all the time say, well, what if these are the same? Then it'd be 0. Well, technically 0 is still a constant. So I would still put plus c. But I don't have to put a plus 0. Right. You're saying that maybe it's 0. But it might not. There's a good chance it's not 0. So I still put the plus c. So that covers me if I have a constant of a positive number, a constant of a negative number, and it even, yes, does cover me if I have a constant of 0. So we want that c there. All right, here we go. I need to get rid of the ln's. So I am just going to apply a base, let's go here, of e to both sides. Okay, bye-bye. Now it's just y equals. All right, we went over this in problem 14. Anytime I have exponents, because keep in mind right now, this is one big exponent. In order to add exponents, okay, I need to multiply things with the same base together, right? And I said this for problem 14. If I have x squared times x to the 5th, that gives me x to the 2 plus 5, which is basically x to the 7th, okay? Now I have this on this side, and what I'm going to do is I'm going to break it apart into my multiplication. So I have e to the ln of 2x plus 1 times e to the c. Okay? If I were to multiply those two things together, okay, if I were to multiply those two things together, I would end up with here, this position right here. All right? So here we go. Let's go. Y, we're going to keep manipulating this. These two things cancel. Boom, and I have 2x plus 1. And guess what? E to the c, e is a number. That would still give me yet another constant. So I'm just going to leave that as a c. This is what I have right now. Okay? This is my equation. I need to find out what C is. How do I find out what C is? I need my initial condition, which is right here. When x is 0, your y value is going to be E. Okay, when x is 0, your y value is going to be E. So I come down here. I want this at, when x is 0, your y value is going to be E. So I'm going to plug 0 in for x and E in for y and figure out what C is. All right, so E for y equals 2 times 0 plus 1 times C. Whew, man, I'm running out of space. So 2 times 0 is 0 plus 1. I get up 1C equals E. So, okay, so E is what my C value is. So all I got to do is plug that back in here into my original equation. And, you know, I've got it. I've got something good. I've got something real good. All right? So let's do that right here. Y equals E. I'm going to put this first. My C is now E. This is real weird. I'm substituting one letter for another. But remember, E is a number. C was a variable. We're plugging the number E into that variable. To the 2x plus 1. Now, if I look at my multiple choice, I don't have E times 2x plus 1. But it looks like if I distribute my E, I get y equals 2ex plus 1 times E is E. I am almost certain I saw this on there. And I did. It is choice B. Again, that first one was a layup. This one was a little bit more work. All right, number 23. The region enclosed by the graphs of y equals x squared and y equals 2x is the base of a solid. Oh, I like these problems. Okay, for the solid, each cross-section is perpendicular to the y-axis. Okay, it is not parallel, it is perpendicular. So it cuts across it. It doesn't run alongside of it. And it's a rectangle whose height is 3 times its base in the xy plane. Which of the following expressions gives the volume of the solid? Okay, first of all, don't fret with this right here, 3 times. Notice that every single answer has a 3 times the integral. Now, I like doing these rotation problems with shapes and all that jazz. Some people don't, but I do. So I'm just going to sketch this out so we have a good visual. Okay? Here we go. And if I graphed these two things, I will graph this one in green. Yep, that was green. Boop, boop. It has a point at 0, 0. It is at 1, 1. Which we'll put right here. Then it is at 2, 4. Okay, so I should probably do this here. Go 1, 2, then here's 0 on the x, 0 on the y, 1, 2, 3, 4. Okay, so the next point is going to be at 2, 4. All right, I'm just graphing y equals x squared. It's going to come around like this. Now it goes through there. That's my x squared equals y. We'll do this one in red. 2x. It's going to start at the origin. It's going to go up 2 over 1. Up 2 over 1. Okay, it's going to cross right there. In the red is y equals 2x. Now, okay, this shape that is all shaded in right here, is going to rotate around the y-axis, which means it's going to cut across the y-axis. So if I were to do a shape, it would kind of look, it would spin around like that, come across, you know, spin around, keep spinning around, whatever, get a little bit further away, whatever. So whenever I do that, okay, and I'm gonna have to use an integral, All right, and I always square my integral. Okay, this is a volume. All right, so we take the area of my shape and I multiply it times the height. Okay, area times height will give me volume. My height is 3. The area is going to be the integration of these shapes. So that's why I take my height and multiply it times my integration of the area. Okay? So if they're rectangles, okay, in this case, what I'm going to do is I always take the bigger function and subtract the smaller one. So I'm going to integrate the bigger one minus the smaller one, and I square it. All right? And I got to have bounds here. I'm going to have some numbers here and some numbers here. Here's the kick. Okay, notice A and B have y variables in there, and C and D have x variables. Since I'm rotating around the y-axis, I want my bounds to be y's, which means I'm going to be an upper bound of 4 and a lower bound of 0. 0 to 4. And they should be y's. Okay, so I can't have x's. Both A and B have 4 and 0 as the upper and lower bounds. Okay, and now I need to take my bigger equation and subtract my smaller. But this is something I always try and drive home. If I'm rotating around the y, my bounds need to be y's, which they are, 4 and 0. But also my equations need to have y's in them. Everything needs to be y's. I need to have y variables. Right now, I have y equals, and then I have my x variables here. My y equals my x variables. I don't want to put x squared and 2x in. I want to change those equations so it's x equals. And I have my y variables, meaning I'm going to take the square root of both sides. So x equals the square root of y. Okay, I'm going to divide both sides by 2. So x equals y over 2. These are the equations I want to use. I want y variables. I want y bounds and y variables. If you don't know how to take or how to consider which of the functions is bigger, whatever is further away from the y-axis. If I go here, this one's further away. Okay, so that's my bigger one. This one, which would mean this is going to be the capital R, the bigger function, okay? The smaller one is the function that's closer, right? So if I start here, the red line is closer, okay? So this one's going to be closer, which means this will be my little r. Okay, does that make sense? So when I rewrite this, I have my 3 on the outside. I have my integration from 0 to 4. I have my big equation, which is a square root of y, minus y over 2, and I have to square that, and I get to say dy, because I'm using y variables. There you go. Here you go. And it's subtraction. It is not addition. That's the difference. Okay, you need to subtract them. Woo! That was a lot of explaining. If I wasn't explaining this, I could have done this quickly. But I'm explaining it because you're here to see how it's done. So you're probably here to get a little bit of an explanation, and there you go. All right, number 24. If the average value, there you go, of a continuous function on the interval from -2 to 4 is 12, what is the integral of f of x over 8 dx? All right, here we go. Anytime I want the average value, I am going to have an integral from, let's call this a lower bound to b. If I'm averaging it, I'm always going to do something. You can either divide it by b minus a, right? When I take the average of like 10 tests, don't I got to divide it by that number 10, right? So you can either divide the whole thing by that number, or dividing by a number is the same thing as multiplying by 1 over that number. And this is how I write it most of the time, just to get it out of the way of the integral. My integral that they give me here, okay, is the integral from -2 to 4. Okay, that means I got to multiply that if I want the average by 1 over 4 minus -2. Okay, and that's of f of x divided by 8 dx. All right, the average value of a continuous function on the interval. This represents my average value, which means this whole thing needs to equal 12. Yeah? 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 Okay. Okay, good. We're good. We're good. We are good. Excuse me there. Just took a drink of coffee. Now, let's clean this up. All right? On the outside here, if I just do this fraction, I'm going to get 1/6. Okay? And then also what I'm going to do from -2 to 4, I'm going to call this 1/8, all right, times f of x dx is 12. All right. All right, all right, all right. Here we go. Now, what's important to note here is the average value of continuous function f on this interval is 12. That means, and the reason I broke this apart is, let's see, can I move this out here? Oh, I can't. I would have to break that apart. All right, this right here, and this is tricky. This would have been tough. This right here is not included in the average value of f. Okay, so I'm going to take this part out, if this makes sense. Okay, I'm going to have this on the outside just hanging out here for a second. Okay, now the average value of a continuous function f, now it is just the average value of a continuous function f right now. Okay, that's it. This 1/8 is just thrown in there in the problem. They gave you the information that says the average value of just f from 4 to -2 is 12. So that's what I have set up here, okay? Keep in mind, you might be saying to yourself, well, then what's happening with that 1/8? What we have set up now is based on the information they gave us, okay? We'll bring this back in and answer the question in one moment, all right? So let me do this. I'm going to multiply at this point both sides by 6. Gone, multiply this by 6. So now I have the integration from 4 to -2 of f of x dx equals 72. All right? Now, this is what I have based on the information they gave us. Now they want to divide it by 8. Okay? So if the integration from 4 to -2 is 72, if I divide that side by 8, what I do to one side, I have to do to the other. This was tricky, so now what they want is really 9. 72 divided by 8. This was tricky. I'm so sorry I even covered the 9 when I did that. This was tricky because what they gave us was only for f. What they want us to solve through an extra operation in there that shouldn't be there if I'm setting it equal to 12. Okay, so this 8, okay, I really should have taken out maybe from the beginning, but we just carried it around because I wanted to show you by taking this 8 out, that's what they gave us. That was tricky. That might have stumped a lot of people. All right, let's come back down to earth and do a problem that's somewhat simpler. Okay, number 25. The figure above shows the graphs of the functions f and g. If h of x is f of x times g of x, what is h prime of 2? The first thing I'm going to do is figure out the derivative, and then I will plug the 2 in for x. So I don't have equations. I just have f of x times g of x. The derivative of the product of two things is the first times the derivative of the second. I don't know what the derivative of g of x is, but I know it's just g prime of x. I don't have the equation. I have a line, that's fine. Maybe I can come up with an equation, but why do all that work? It is the first times the derivative of the second plus the second times the derivative of the first. So now that I've established what h prime of x is, now I can put in the 2. So I need to figure out f of 2 times g prime of 2 plus g of 2 times f prime of 2. The good news is prime or derivative means slope. And these are lines, so the slope is going to be the same no matter what. That's going to be easy. What's even easier is f of 2. Here's 2. F of 2 is right here. That has a y value of 3. So this is 3 times, I'll leave that blank for right now, plus g of 2. Well, that's right here. That has a y value of 1 times. Okay. What is the slope? That's times, not minus. What is the slope of g? I don't know. I mean, if I start here, I go over 1 and down 2. So that's over 1 and down 2. So that's that's 1 over negative 2. Plus the slope of f. F starts here. We'll go here. It goes up 1 and over 2. Up 1 and over 2. So wait a second, it's rise over run. The first, well, it's negative, oh, look at me go. It's negative 2 over 1. Yep, it goes down 2 and over 1. Almost made a boo-boo. The slope of f of x goes up 1 and over 2, both in a positive direction. All right, well, we got negative 6 plus a half. So that'd be negative 5.5, which would be negative 11 over 2. Okay? Choice D. Woo! I mean, take your time. Don't go fast. It's when you make boo-boos. Woo! After 23 and 24 were difficult, we have a couple of easy ones in 25 and now 26. Rule of thumb, when you are taking the limit of anything that goes to infinity, you always want to keep the biggest term in the top and the biggest term in the bottom. Now, anytime the variable is in the exponents for a number greater than 1, that's bigger than just a variable on its own. So I don't care about this if I'm plugging in infinity. So I have the ln of e to the 3x over x. Biggest term in the top, biggest term in the bottom. Now, I try to simplify before I plug in infinity. Okay, well, the great thing is ln and e cancel. This comes down. So I have 3x over x, and I can simplify even more. My x is, boom. Oh, beautiful. Wow. That was an algebra problem. That wasn't even a calculus problem. I mean, it was. So what happened to infinity? We have no more x. There's no x to plug infinity into. It is just 3. All right, number 27. It's another problem that gives us a little bit of a mental break. And I hate to say these are easy, but this one is pretty easy. All right, the graph of f prime, the derivative of f, is shown above. This is the derivative of f. This is not the graph of f. It is the graph of the derivative. That's important to know. Which of the following statements must be true? First of all, I tell my students that no matter what, if you have a graph of the derivative, that means the y value is the value of the derivative at that point. What do I mean? The value of the derivative right here, whatever x value this is whatever the y value is here. Okay? Because y is the derivative. So this is really the derivative. Okay, any y value for any coordinate is now the derivative because y is the derivative. That's what we graphed. All right, you need to understand that. All right, the next thing I like to do is I like to say, okay, well, if x is 0, okay, whenever x is 0, okay, excuse me, let me restate that. Whenever y is 0, that means my derivative is 0, correct? Right here. this root right here, all right? That has a y value of 0. That means my slope is 0. Anything above it, anything that's above the line here, okay, above the x-axis, has a positive y value, right? So all of these would have a positive slope or positive derivative. Anything below the x-axis, isn't that a negative y value? It is, and aren't y's my slope? So I would have a negative slope or negative derivative, okay? So let's take a look at our choices here. F is continuous on the open interval from A to B. So from A to B, you can take the derivative everywhere. The rule of thumb is if you can take the derivative, it has to be continuous. So if it is differentiable, it is also continuous. So that is true, okay? F is decreasing on the open interval from A to B. Now keep in mind, this is saying F, this is not saying F prime. So whether F is increasing or decreasing means if the slope or derivative is positive, it's increasing. If the slope or derivative is negative, it's decreasing. This is saying it is decreasing through the whole interval. This is increasing the original function. The derivative is positive in here, so it's increasing. So it is not just decreasing the whole place. And we're talking about f. Okay, we're referring to f, the original function. Okay, what we have here is the slope of f. Okay, now the graph of f is concave down on the open interval from A to B. Concavity is second derivative. Okay, that would mean second derivative would have to be negative. Okay, how do I get second derivative if I have first derivative? The second derivative is the derivative of the first derivative. That should make sense. But don't forget, derivative is also slope. So the second derivative is a slope of the first derivative. This, my friends, is this first derivative has a slope that's constantly negative. So the slope of my first derivative is constantly negative. So the second derivative is constantly negative. If the second derivative is negative, it's concave down. That's true. So 1 and 3 are true. Choice C. There you go. 28. We now have a problem that's going to require some moxie again, like those earlier two. An isosceles right triangle with legs of length s has an area of 1/2 s squared. Okay. At the instant when s is 32, the square root of 32, centimeters, the area of the triangle is increasing at a rate of 12 square centimeters per second. Okay. At what rate is the length of the hypotenuse of the triangle increasing in centimeters per second squared? So if I call hypotenuse h, okay, if I call hypotenuse h, well, let's not even get there first. Let's do what they give us first in the order they give it to us. Okay, so obviously I need to find the rate that the hypotenuse is increasing, so it should be a positive value. But I need to do that with what they gave me. So area is 1/2 s squared. So area equals 1/2 of s squared. Now, at the instant s is the square root of 32, the area of the triangle, that's this, is increasing at a rate of 12 square centimeters per second. So the change in rate of area, dA, with respect to the side, is, okay, let me take the derivative here. 1/2 times 2s ds. Anytime I take the derivative of an s, I need to put ds next to it. Okay. 1/2 what do we got here? ds. They say that's 12. The rate of the area is 12. So this is my 12. My 2 and my 1/2 go bye-bye, because I multiply them, they just equal 1. That equals s ds. They want this at what? The moment s is a square root of 32. Okay? So now I'm going to substitute square root of 32 in for s. So 12 equals a square root of 32 ds. Okay, and to find ds, okay, the change in rate of the side, and just divide by the square root of 32. So you're saying to yourself, why do we need that? Okay, so ds, I'm going to write this up here. ds equals 12 over the square root of 32. This is going to be helpful because now I need to find the rate of change of the hypotenuse. Keep in mind, I have an isosceles right triangle. Okay? We can call this side A, this side B, and this side C. These are the same. All right? So I need to find the rate of change of this side, the hypotenuse. I'll call that DC. That's what I'm trying to figure out. So how do I figure out, okay, what equation can I use, all right, to figure that out? Well, the Pythagorean theorem. And since this is isosceles, okay, and these A and B should be the same, let's call, these are really our S value. We'll call these both S, the sides of the triangle. Okay, it tells you right here, the isosceles right triangle with legs of length S. These are the legs. Okay, they have a length S. All right, so I have A squared plus B squared is C squared. So I have S squared plus S squared is C squared. And if I clean this up, I can combine my left side and just say that's 2S squared equals C squared. All right, I need DC. That is a rate. That means I need to take the derivative of this. Okay, so I got 4S ds. Okay, anytime I take the derivative of an s, I have to put ds next to it. Okay, this is called a related rates problem. Anytime you take the derivative of a radius or a height or a hypotenuse, you've got to put the dr for radius next to it, or dh for height. Or in this case, I've got 2c dc. And dc is what I'm trying to figure out. This is good. This means that I should have, this is what I'm trying to figure out, which means I should know a c value here. I should know an s value here. And I should know a ds value here. So let's fill in what we got here. I want this. All right, here we go. I mean, technically, if I want to divide both sides by 2, this goes bye-bye, and this becomes 2. And I work with smaller numbers. So now I've got 2s ds equals c dc. That might be nicer. All right, so here we go. All right, s, they want this at the moment my side is the square root of 32. Okay, so my s is the square root of 32. So I've got 2 times the square root of 32. ds we just figured out. We kept that up here. ds is 12 over the square root of 32. So that's times 12 over the square root of 32. Okay, equals dc, I need c. How am I going to figure out c? Well, I know what s's are. Aren't s the square root of 32? I'm just going to use this to figure out c. 2 times the square root of 32, okay, that's my s. I need to square it, equals c squared. All right? The square root and square cancel. So 2 times 32 is 64 equals c squared. So c is 8. That's nice. That's just going to plop right down here, 8. All right, well, let's clean up. Let's clean up. Like, this is very algebra heavy, but you know what? The math is not that difficult. So I'm going to go here. We'll go gray. Radical 32 on top. Well, I thought that was gray. And radical 32 on the bottom cancel. 2 times 12 is 24 equals 8 DC. And now I just divide by 8. That was a lot of work. But you know what? We got it right. It's nice. Well, I mean, I hope we got it right. We did. We did. I'm going to come up here. And the answer is B3. I mean, look at all that work. That's a good amount of work for multiple choice problem, especially without a calculator. But anytime you don't have the calculator, the math is doable. 29. Here we go. This one isn't too difficult. Which of the graphs, the graph of which function, I should say, of the following functions has exactly one horizontal asymptote and no vertical asymptotes? Horizontal asymptotes are the limits as x either goes to positive or negative infinity. Okay, and no vertical asymptotes, I just say it's whatever x value makes the function undefined. Okay, so whatever x value makes my function undefined, all right? So I want to find out, first of all, let's do this one. I think it's going to be easier to do. Which equation or option here will never be undefined? Because there should be no vertical asymptotes. This would have to be -1 plus 1. But the thing is, whatever number I put in for x, I'm squaring, so it'll always be positive. This denominator will never be 0. So it will never be undefined. So this has no vertical asymptotes. Good. I can make that a -1 by making x -1. If I cube -1, it's -1. And the bottom will be 0. So that would have a vertical asymptote. But remember, I don't want any vertical asymptotes. All right. Well, I can make this 1 by making x 0, because anything to the power of 0 is 1. And then 1 minus 1 is 0, so that would be undefined. And last but not least, I cannot make this a -1. Okay, that will always be a positive value. Even if my exponent is negative, it just makes it a smaller, it makes it into a fraction, the expression. So this, okay, so A and D have no vertical asymptotes. All right? So now it should have one horizontal asymptote. And I'm going to start with A, and that's where we're going to end because I believe that's our answer. Okay? If I put the limit as x approaches positive infinity and the limit as x approaches negative infinity in, I should get the same one answer for both because I only have one horizontal asymptote. So I keep the biggest term on the top, which is 1. I keep the biggest term on the bottom, which is x squared. I do the same thing here. And now I plug in infinity. 1 over infinity squared is 1 over infinity, and that would approach 0. Y equals 0 is a horizontal asymptote. Let's try negative infinity. I'm going to plug 1 over negative infinity squared. What happens when I square a negative number? It becomes positive. Okay, and that still is 0. And it has one horizontal asymptote at 0. That's choice A, and that's your answer. Number 30, finally, we are done. All right. For a certain continuous function f, the right Riemann sum approximation of the integration from 0 to 2 of f of x, z of x with n subintervals of equal length is 2 to the n plus 1 times 3 to the n plus 2, all over n squared, for all n. This is going to be the biggest help for us. What is the value of the integration from 0 to 2? I really don't see questions like this a lot, the way it's worded and asked. I mean, I had to do a little bit of research into this. I mean, trust me, there's times I got to learn stuff too, or stuff that I had forgotten, or just it's a different way that they ask a question. All right? If I am going to, okay, if I'm going to find a Riemann sum, I'm going to find values, but it's for all of n. Okay? If n is my x, so to speak, it's my independent variable. It's my input, okay? What is the output? So I want to find the limit as n goes to infinity for all n, okay? Oh, I put an x. I had x on the brain. It should be n, okay? For all n of my function right here. 2 to the n plus 1 of 3n plus 2 all over n squared. All right? So let me FOIL out the top, and then we're going to keep the biggest term in the top and biggest term in the bottom. Again, setting this up, knowing that you had to do the limit as n goes to infinity for all of n. Again, we have a graph, right? Let's say we have n and f of n, okay, or an x or f of x or whatever. For all of n, everything is going to cover it. That's infinity, okay? Could be positive and negative infinity. Could be both ways for all of n. If we wanted to say plus or minus, we could, okay? And we probably should, but let's just do our foiling. We have 2n plus 2 times 3n plus 2. Okay, and then if I FOIL that, I'm going to get 6n squared plus 4n plus 6n, so that's plus 10n. That's 4 plus 4 all over n squared. Again, if we're taking infinity, just like one of the problems we just did, I only want the biggest term. The biggest term at the top is 6n squared. The biggest term at the bottom is n squared. Let's simplify it. Okay, boom. It's very simple once you set it up, but I think it's the realization of how you got to do it. That's a tough, I mean, the way they ask that, that is not a real common way they ask things. But now you know. Ring that bell, follow me. We are going to do part 1, section B, or is it section 1, part B? It's section 1, part B, and these are going to be, there's 15 problems, and you will get to use a calculator there. Can't wait to see you for that one. Okay. We're done. Again, ring-a-ding-ding, let that bell for me. Follow me. I'll see you guys later. Bye-bye.